Have you ever stopped to think about the incredible, invisible balancing act that's happening inside your body right now? It's this amazing, self-regulating system that's constantly working to keep you alive and thriving, no matter what you're doing. So how on earth does it manage all of that? Well, let's dive in and take a look at this incredible internal dance. I mean, think about it for a second. Whether you're out running on a hot day or stuck in a freezing office, your internal temperature stays remarkably stable. How does your body pull that off? This one simple question is really the key to understanding a much, much bigger process that's running your entire body. The whole idea is actually pretty simple, and it's almost exactly like the thermostat you have in your home. Your body has this ideal temperature it wants to maintain. So if you get too hot, your biological AC kicks in. You start to sweat. And if you get too cold, the internal furnace fires up. You start to shiver. The goal is always the same. Get back to that stable, comfortable state. And here's the wild part. This isn't just about temperature. Your body is jam-packed with thousands of these little thermostats all working at once. They're constantly tweaking your heart rate, your blood pressure, your oxygen levels, you name it. It's this massive, perfectly coordinated effort happening every single second of your life. This whole master process, this constant balancing act, has a name: homeostasis. It's the incredible ability of your body to keep its internal environment stable, creating the perfect conditions for all your cells to do their jobs. It's really the fundamental reason you can survive and thrive in a world that is always changing around you. Now, it's super important to understand that homeostasis isn't about being perfectly still or unchanging. It's what we call a dynamic equilibrium. That just means things are always fluctuating a little bit, but they're kept within a very tight, healthy range, thanks to all those tiny adjustments. And this balance is absolutely essential for survival. When it gets disrupted, that's when you can get sick. So, how does the body actually pull off this constant balancing act? Well, its main tool, the absolute foundation of homeostasis, is a mechanism called the negative feedback loop. You could say negative feedback is the how-to guide for homeostasis. It follows one simple, brilliant rule. Whenever something strays too far from where it should be, the body kicks off a response to counteract that change, to reverse it, and push everything back to the middle. Let's walk through it. It all starts with a stimulus. Let's say your body temperature starts to rise. Receptors, little sensors in your skin, detect this change and shoot a signal up to the control center, which is a part of your brain. Your brain processes that info and then tells an effector, in this case your sweat glands, to get to work. The response? Sweating. And that sweating cools you down, reversing the initial change and bringing you right back into balance. Simple as that. Okay, theory is great and all, but let's see how this stuff actually plays out in real time inside your body. We're going to look at two amazing examples: how you regulate temperature and how you regulate your heart. This right here, 37 degrees Celsius, or about 98.6 Fahrenheit, that is the magic number. It's the set point for your core body temperature. Your body's entire thermal regulation system works around the clock to make sure your core never deviates too far from this crucial number. And believe me, maintaining that temperature is a constant battle. I mean, just look at this runner. Their muscles are generating a ton of internal heat, and at the same time, they're getting blasted by heat from the sun and the air. The body has to perfectly balance all of these forces just to keep that core temperature stable. It's incredible. And here's that negative feedback loop in action, clear as day. If your temperature shoots up, you sweat. Plus, the blood vessels in your skin widen. That's called vasodilation, to release heat. On the flip side, if your temperature drops, you shiver to generate heat, and those same blood vessels get narrower, vasoconstriction, to hold on to heat. See? Two opposite problems, two opposite solutions, all just to get back to that 37 degrees sweet spot. Now, let's talk about the heart, which is even more sophisticated. Your heart has its own built-in, or intrinsic, pacemaker system that lets it beat all on its own. But it also has an extrinsic control system, where your nervous system and hormones can jump in to speed it up or slow it down, depending on what your body needs at that exact moment. That built-in system starts right here at the Sinoatrial node, or SA node for short. This tiny little patch of cells is the heart's natural pacemaker. It's what generates the electrical spark that kicks off every single heartbeat, setting the fundamental rhythm of your entire life. Okay, so up until now, it's all been about stability, right? Bringing things back to the middle. But what if, sometimes, the body needs to do the exact opposite? For a few very specific, very critical reasons, the body will actually push itself away from balance on purpose. And it does this using a process called positive feedback. And here is the key difference. Negative feedback is like hitting the brakes. It reverses a change to keep things stable. Positive feedback is like slamming on the gas pedal. It takes a change and makes it stronger and stronger and stronger. It's not about balance, it's all about pushing a process to a very rapid conclusion. And this is where we see it happen. During childbirth, pressure on the cervix triggers the release of a hormone called oxytocin. Oxytocin causes even stronger contractions, which creates more pressure, which releases more oxytocin. This cycle just keeps amplifying itself until the goal, delivery, is finished. The same thing happens with blood clotting. A few platelets get activated, and they send out signals to activate even more, quickly forming a clot to stop you from bleeding. It's a system built for fast, explosive results when you really need them. So at the end of the day, homeostasis is really that quiet, relentless manager working behind the scenes. It's this constant, invisible balancing act that protects your internal world from all the chaos of the outside world, letting every single system in your body work at its absolute best. It really is the secret to our stability and our survival. And that leaves us with one final, pretty important question. If homeostasis is so critical for keeping us healthy, what happens to our bodies when this delicate balancing act finally fails?